Let's have a quick look at the equality of values. Now I can use this Boolean question, double equal sign, I'm using it here as a function. And I'm going to say, is 5 equal to 5.0? As human beings, we would say that's exactly the same thing. And indeed, we're going to get this value of true returned. So we're just going to ask, are the values the same? But what if we want to ask something such as, is the value and the type exactly equal to each other? And therefore, there we can use three equal signs, or this is function. So right there, we can use this 3 equal signs, not 2 as we did there, that only asks about the value. If we want to ask about value and type, we can use the is function or 3 equal signs. And now is 5 equal to 5.0, and we get a false value back because one is an integer and the other one's a floating point value. So the values might be the same, but the types are different. So what happens to these user-defined types of ours? I've got two instances of my vector underscore 2D type. I've got vector underscore A and vector underscore B. And you see I pass exactly the same field names. And remember, the type is going to be a 64-bit floats anyway. So they look exactly the same. And if I ask, are they the same though, I'm going to get a false return. They are not, because what happens with these is the address of the memory is actually checked where these two instances are saved, and that's not the same spot. And therefore it returns a false value. So just be aware of that. So let's talk about defining methods for functions that will use our user types. Now just consider the plus function. We just write plus, remember the open and close parentheses, and we can add, for instance, 2 values there, 2, 2, and it would return a 4. When that function is called and we pass values that are 2, 2, the method that will be used would be that of 2 integers, 2, 2. If I were to add my 2 instances of my vector type, say vector underscore A and vector underscore B, I would get this error, method error. The closest candidates would be any because it cannot find a method for vector underscore 2D, vector underscore 2D. I have to create those methods for that function, the plus function. So let's look at the plus function itself. Remember, it's one of the base functions in Julia. If I were to just do that, we see there's 171 methods defined for this plus function. And if we scroll down here, we see in64. So when I pass those values, 2, 2, it would use this method for the plus function. And we can scroll down and we can see there are indeed 171 of these defined. Now, what do we do with our user type? We can now modify this, and we have to decide before, and you are going to create that type based on the need that you have, and you know what you want to do if you want to add 2 instances of that type. First things first though, we have to import the plus function, and that's simply written as import base.plus, and we execute that. It is now imported. Now we are going to define what to do when we try and add 2 instances of our new type. And what we're going to do is the following. We write plus, it's the plus function, and then we create this reference to 2 instances of our new type. You can call them what you like. I've called them U and V to just specify 2 instances of my vector underscore 2D type. And I use the double colon signs to show Julia that we are dealing with this specific type that we created. And what to do, equal, it'll be vector underscore 2D, and what we've decided to do is to take the field names that are similar in our user type. Remember, we had 2 field names, X and Y. So we take the first instance's field name, so u.x, and we add to that v.x. So whatever the first one was and the second one, the first instance and the second instance, their field values referring to x will be added, comma, and the same for the second field names that we had there. And that is how we decided to create, or what to do with a plus function with these two types. Of course, depending on the type that you create, you can decide to do something else when you want to add two instances of that type. Now, remember there was 171 methods for the plus function, and now we see we have the plus as a generic function. Now with 172 methods, we've created our own method. We've overloaded the methods for the plus function, and now I can say please add vector underscore A and vector underscore B for me, and it's done that. It adds those two. It's still a vector underscore 2D type that we have, and the X field values and the Y field values of the two instances have been added together as we have defined them. So you can see it's very easy to define your own methods for a Julia function. Next up, we're going to look at constraining the field values.